So finally, we're going to look at the three classes of pulleys that we've talked about, and we're going to look at the mechanical advantage of each of these pulleys. The first pulley we actually learned about, is the single fixed pulley, where the pulley is attached to an actual object. And here's the actual wheel and axle. So this single fixed pulley, all right, which will have the effort force coming in at an angle, going around the pulley, and you'll have a load being suspended. So your load is going upwards and the effort force comes down. Now, this does not have a mechanical advantage in that you still, using this type of pulley does not make you have to put in less effort. The bonus here is that it allows you to move, let's say, an awkward or a large sized object that you otherwise couldn't maybe carry, or maybe it's in an awkward spot and you want to get it out of that spot. A single fixed pulley is good for that. Now, the second type of pulley, which is also a single pulley, is the single movable pulley, where we've got our string or our chain or our rope attached to some kind of support beam, and our pulley is actually dangling. Okay, so the pulley will have the actual load attached to it. And what ends up happening here is the string comes into the pulley, goes around the pulley, and gets pulled up. Now, the effort is going in this direction. The reason that the single movable pulley has a higher mechanical advantage, it actually ends up cutting the amount of effort that you need to put into the object by half, because this rope right here ends up absorbing or taking care of half of the actual load. So you're left with the second half of the load, so it feels half as light. So if we go back here, you would feel 100% of this load. In a single movable pulley, you're only feeling about 50% of the load, which means you could probably lift twice as much as you would be able to with a single fixed pulley. And finally, we have what's called a multiple pulley system. So a multiple pulley system can have a variety of fixed and movable pulleys. It can have multiple pulleys attached to one another. And what ends up happening here is, if let's say we've got, three actual pulleys here, and we attach a rope, or we have ropes going through a variety of these, we're going to see that for every pulley that's added, a portion of the actual effort force needed is removed. So we have this pulley where the load starts. This is your starting point down here. And the load is actually balanced, and the effort force comes off in this direction. You can have your load, let's say, dangling from this one. It's actually going to move the load, all right? And actually, no, your load should be down here. Your load is not actually attached to the pulley, because this is kind of a fixed situation. This load and this effort force ends up being much less than even a single movable pulley. The catch here, though, is that at some point, you're going to have too many pulleys in your system, because the more pulleys you have, okay, the more friction you're going to encounter. And we know that friction is a force, and it's a force that opposes the motion. If you want to go this way, friction's trying to make you go in the opposite direction. It's a hurdle or an obstacle for forward motion. And we know that at some point, we're going to have too many pulleys in the system, and pulleys actually gain a lot of friction, because a pulley is a wheel on an axle. And not only is the axle We're going to draw the areas of friction in red. Not only is there friction all over the axle, but let's say we have a rope going around the pulley, around the wheel. Everywhere that the rope comes into contact with the actual pulley, we have friction. So we want to try, because friction is a much bigger factor in pulleys than it is in levers. We want to try and minimize the amount of friction. So what we end up having to do, we can do about three or four things to lower the amount of friction. Number one, okay, we can have less pulleys in the system. So less things touching one another. But that may not be an option. If you only have a single movable pulley or a single fixed pulley, well, you can't get rid of any more pulleys. The next thing that we can do is we can use very smooth material. We know, we played around with spring scales and friction, and we know that the bumpier the surface, the more friction there is. The third thing we can do is we can use a lubricant. Okay, case in point, when we put oil in the engine of the car, when a ring gets stuck on your finger and you use dish soap or butter to pull it off, or oil. Okay, a lubricant is going to coat both surfaces and make them more slippery. All right, and if something is slipperier or more slippery, then it's going to have less friction. And the really cool thing that we can do with pulleys is we can use ball bearings. And we know that ball bearings lessen friction, because instead of having the entire axle coming into contact with the actual pulley, we end up having a pulley, all right, with a very small axle, and the axle well is here, and instead of having 100% contact like we do here, we've got actual balls, and I mean, these are not drawn to scale, obviously, but instead of having contact everywhere, it only comes into contact where the actual balls touch the wheel and the axle. And because the balls roll, that contact is always very small. So ball bearings can lessen the amount of friction. We see them a lot in things like rollerblades. If rollerblades had a lot of friction, the wheels would wear out that much faster.